happy e-learning week 2. I just want to say thank you to all of you for turning everything in last week. I had a 100% participation in your class, so that is awesome. Keep up the great work. I don't know what this light is doing. It's making me glow. I don't know. So, I'm just going to go through a couple things for this week. Hopefully I start sending more of these videos out because I miss seeing you and I hope you miss seeing me. I'm looking forward to possibly video conferencing with you guys later this week, so look on email for details on that later. So I'm going to turn the camera around and go through a couple things on the Google Doc with you.
So I'm just going to apologize now too because I know videotaping the screen, it gets a little grainy. So just work with me. All right, so this is this week's Google Doc. So hopefully this format worked well for you guys last week. I'm going to continue to do it this way. I think it's just easier to lay out the week all in one place. Hopefully you found this and are watching this video because this is where this video is going to be posted. This week we want to review function composition from last week. So that's the f of x, or like g of f of x. That sort of stuff. So I'm going to go through those. You're going to complete a Desmos activity. Take notes with your note-taking guide again today. And then we're also going to review inverse functions, which is what you're going to take notes on today. So I'm going to kind of go over all of this with you right now. So if you are going to tune out instead of follow along with me, that is fine. Just make sure that you guys are keeping up with your work. You guys are doing an awesome job. If you ever have any questions, feel free to reach out to me via email. Your grades are all updated as of this morning. So if you're missing anything on there, please reach out to me because those are due by 4 o'clock today on Tuesday. So if you want to tune out, go ahead. Otherwise, I'm going to kind of click through some things and hopefully help you. So if we review function composition, so if you guys also saw that link is there from the video I sent out last week, helping with domain. So a lot of you found that video helpful, finding domain when you're finding the composition of functions. So just something that you might want to review if you haven't seen that yet. So when we're talking about function composition, so we're going to scroll down here. When we're looking at notation, you can write it in either way. Both are read g of f of x. So this is like g of f of x or g of f of x. So both are read the same way. It's just two different notations meaning the totally same thing. What is function composition? Hopefully you guys can all answer this after you took notes on it last week. A composition involves two or more functions. In a composition, you use the output of one function as the input of another. So if you click this link, there's also a flow chart here that kind of highlights as you go through. So you do f of x, whatever you get for f of x, you plug into g of x. If you're looking at f of g of x, you work inside out. So f of x is in the very most inside, so I want to do that first, and then take g of whatever that f of x is once I plug x in. So you can follow through that flow chart. So if I have two functions, f of x equals 2x and g of x equals x minus 1, if we're looking at f of g of x, okay, we're going to perform the right side g of x first. So f of g of x. Again, they have a new notation here too, so they kind of just put the f of g in the outside brackets. So you're going to do g of x first, depending on what x is. So here g of 5. So I plug 5 into the g of x function. So 5 minus 1 is 4. Then I'm going to take 4 and plug that into my f of x function. So 2 times 4 is 8. And you can follow that all the way through. If you click up here, it kind of highlights for you step by step what happens. And as you can see, we always go right to left. And what you're going to explore today is, are these compositions cumulative? Is f of g of x equal to g of f of x? Yes or no? So at this time, after that quick review, I want you guys to go ahead and go back to the Google Doc, and you're going to click on this Desmos activity. But in order to complete that Desmos activity, I want to show you guys something. So in Desmos, once you have an f of x defined and a g of x defined, you can just put f of g of x or g of f of x like this in this notation, and it will automatically graph that for you. You don't have to plug in the like x plus 2 into the x squared. It will automatically do that for you when you go to graph. So as you guys go to do this activity, the composing functions exploration, you're going to need to know that. So go ahead and complete this at that time, and look forward to another short video on here from me.